Okay, welcome to this video. Alright, we're going to be talking about position, distance, and displacement here. If we're to find the position of an object in space, we'll have to do that by comparing its location with that of a reference point. Usually, to get this reference point, we draw two perpendicular lines intersecting at a point. Okay, this point of intersection is called the origin and will be used as our reference point. Okay, note that the horizontal line is called the x-axis, also known as the axis of Abscissa. Alright, the vertical line is referred to as the y-axis or the axis of ordinates. Okay, the origin, that is our reference point, is our 0 point. Okay, so you can see 0, 0. That means both the x-axis and the y-axis is at a 0 point at this origin. Points on the x-axis to the right of the 0 point are positive, while points on the left axis are negative. Points above the 0 point on the y-axis are positive, while points below the 0 point on the y-axis are negative. Okay, so the position of any point is determined by the value of the two coordinates. So if this is a stone and we're trying to locate the position of this stone, we're going to be able to find it by knowing the value of the two coordinates, all right, the x and y. Okay, so we usually put them within a bracket like this. Okay, x in the bracket represents the distance of that position on the x-axis, and y here represents the distance of the position on the y-axis. So you can see this dotted line marks the distance from here to here on the x-axis, while this marks the distance from here to here on the y-axis. Okay, as an example, let's locate the points on a graph: a minus 4, 1, b minus 2, 5, c minus 2, 7. So let's draw our axis. Okay, now if we need to locate minus 4, 1, minus 4 is on the x-axis and 1 on the y-axis. So we have minus 4 on the x-axis here and 1 on the y-axis. So this is that point. Then we have minus 2, 5. So minus 2 on the x-axis and 5 on the y-axis. We have 2, 7, 2 on the x-axis and 7 on the y-axis. So we have that. So that's how we can locate positions in space. Alright, distance and displacement. Displacement is the change in position of a moving body in a particular direction, or the shortest distance between the final and initial position of a body, while distance is the ground covered by an object to get to its final position from an initial position. So let's say we have a bus that moves from point A to point B and then to point C. Okay, what is the distance covered and what is its displacement? Okay, so if we look at this, we'll see that the distance covered is AB plus BC. That's the distance covered. Remember, distance is the ground covered by an object to get to its final position. So it starts from here and ends here, but the ground covered is this, A plus B, B plus C. Now, what's the displacement? The displacement is the change in position of a moving body in a particular direction. So between the initial position and the final position, the displacement is AC. This straight line here, which is just the change in the position of the body from here to here. So AC is our displacement. Okay, so let's look at frame of reference. Frame of reference is a relative reference point from which judgment is made. Okay, so to understand this, let's take an example. We have a guy who is an observer on the road. Okay, and then we have a truck with a guy on the truck and a ball. He's throwing this ball at 5 meters per second, but this truck is in a motion of 10 meters per second. So you will see that as this guy throws this stone, okay, the stone moves at 5 meters per second to him because he is standing on a frame that is moving at 10 meters per second. So to him, this moves at 5 meters per second, but to the observer, from the observer's reference frame, this stone moves at 15 meters per second. Okay, because he is standing still, so he sees the full 15 meters per second. This guy isn't standing still, he's moving at 10 meters per second, so he can see only 5. Okay, so that's frame of reference.